today are different, what are called solids. So the first one is a prism. That's going to be formed by two parallel congruent polygonal faces. So when it just says congruent, it means those two are going to be the same. Okay, so you have the two bases. What is the base here? What's the shape? A triangle. So that would be called a triangular prism. And those are connected by faces that are parallelograms. Okay, so if you think of this around an edge, okay, this would be a triangular prism here. Okay, so the base is going to be the top that's a triangle, the bottom that's a triangle, and then here are my edges. Okay, this one actually looks like a square or rectangle. And so if you have a triangle, how many faces do you have on the sides? You have three. Okay, the next one is a cylinder. Okay, so a cylinder is formed by two parallel congruent circular bases. Okay, and I do not have a cylinder. But I always think of a cylinder like a can of vegetables, right? Can of corn or can of green beans. Okay, and those are going to be cylinders. Now this is going to be a curved face that connects the bases. You have a pyramid. So a pyramid is formed by a polygonal base. So it could be a triangle like this one. It could also be a square. And those are going to meet at a common vertex. Now you guys are used to seeing a pyramid where the point is directly in the center, but you can see here it doesn't necessarily have to be in the center. Okay, this is usually the pyramid you guys are used to seeing. It has the square base, but you can also have a pyramid that has a rectangular base. Okay, and then the cone, that's formed by the circular base and a curved surface that connects the base to the vertex. Okay, so the cone we know is a circular base here, okay, and then the top is going to be curved. And we're going to have some special terms for those types. So here are just some other types of prisms. So triangular, rectangular prisms. This would be a pentagonal because the bases are both pentagons, or a hexagonal, which has the bases that are hexagons. You have a triangular pyramid, a rectangular pyramid. You could have a pentagonal pyramid or a hexagonal pyramid. Okay, so whatever it's called, that's going to represent what the base is of that object. All right, and then let's go to the next page. So we're going to classify three-dimensional figures. It says name the vertices, edges, and the bases. Okay, so first we want to look and see what our shape is here. Okay, all of these are going to be the same length, which means it's going to be a cube. A cube is a type of rectangular prism. So a cube is a special type of rectangular prism. What makes the cube special? All the faces are. Okay, they're going to have the same length, same height, same base, and that's because all the faces are what shape? It's a square. Okay, good. So this is going to be a cube. Then what we're going to do is name the vertices, the edges, and the bases. And I'm actually going to do that with you. Okay, so because it is a cube, all the faces are squares. Okay, now the vertices are going to be where two edges meet. Okay, so the vertices are where two edges meet. this one, your vertices are going to be A, B, C, D, E, F, G, and H. Okay, so all of those are points where two of the edges meet. Right, and now we're going to label what the edges are. Right, now the first edge, I like to go around the top first. So AB is my first edge that I'm going to name. Each one of these are segments. So AB, and then I would have BC, CD, and then DA, or you could call it AD. So I like to do it in a systematic way just to make sure that I get them all. So these are going to be all the edges on the top. The next one I did is all the edges on the bottom. So EF, FG, GH, and HE. Now again, you could label these either way. So if you had FE, GF, HG, EH, that would be perfectly fine too. But you don't have to put EF and FE because that's the same edge. Okay, now the only edges left are the ones that connect the two bases. So to connect the top square to the bottom square, I would need edge AE. Here I have BF. Here I have C connected to G. And then the last one I have is D connected to H. Okay, so notice that for this one I have how many edges? I have 12 edges. How many vertices did I have? 8 total. Okay, and then the last thing I have to name are the bases. Okay, remember that the bases should be parallel to each other. Right? Now, if your base is a square like we have here, then we are just going to name it with the 4 vertices that make up the 2 squares. So on the top, the base is ABCD, and the bottom base is EFGH. Okay, and then we're going to do the same thing with B. So the first thing we want to do is classify the shape. Okay, so is this going to be a prism? If it's a prism, what does it have? Let's look back at the front. Okay, so it'd be 2 parallel congruent bases. So we don't have 2 bases. How many bases do we have? 1. So it's either going to be a pyramid or it's going to be a cone. What's the difference between the pyramid and the cone? Yeah, right. The cone is going to have the rounded sides, and the cone is going to have, what is your base? A circular base. Okay, a pyramid can have any polygon as its base. Okay, so what kind of polygon is our base for this one? It's a, yeah, it's a pentagon, so we're going to call it a pentagonal pyramid. Okay, and it's pentagonal because the base is a pentagon. Okay, if it was a square, if base was a square, we'd say it's a square pyramid, or a rectangle, a rectangular pyramid, or a hexagonal pyramid. Okay, so like Megan Trainor says, it's all about that base. That's how I'm going to name it. Okay, and then your vertices. Okay, so Sam, what are my vertices going to be for this one? Yep. F is one of them, yep. What else? Yep. Yep. And I'm just going to put them in alphabetical order. But you got them. A, B, C, D, E, and F. Okay, so now we're going to do the edges. Yep, and for these vertices, I had how many vertices for this one? There were 6, right? So 5 from the bottom, 1 from the top. Okay, and then my edges, I like to start with AB. And then Logan, what's my next one? Yep. And then Caitlin after BC would be? Yep. And then Sierra after CD? DE. Avery after DE? Say it again. EA, yeah. Okay, so that's going to bring you all the way around the bottom, and then the other edges are going to be from the top to each vertice. So the first one would be F to A, or you could also say AF, that would be fine too. And then F to B, and really F is going to go to every single vertice that's on the bottom. So F to D, and then F to E. And our edges, we had how many? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 10 edges total for this one. Alright, and then we're going to do the base. Alright, and then Xavier, what would we call the base for this one? And then, so the name of the pentagon is just going to be the, yeah, the vertices, right? That created up. Yep, so it would be A, B, C, D, E. Okay, now for a pyramid, the base isn't going to be parallel to anything because you only have one base. Okay, so one base for a pyramid. Alright, and then the next thing we're going to talk about is something called a net. Did you guys do any nets last year? Okay. So describe the three-dimensional figure that can be made from the given net. So basically what this is a shape, but it's unfolded. Okay, so it would be like if you unfolded the shape and made it flat. So like for A, all of these are what type of shape? They're all squares. So when you unfold it, it makes a, what would this one make? A cube. So what I do is I think of this as if you had this and then you folded up all of these 4, that would make the sides of your cube, and then the last one, the one that's hanging off there, would close your cube and make the top of it. Okay, now this one, see how it has a circle? Okay, so there's only a couple shapes it could be. It only has one circle, which means this is going to be a what? A cone. Okay, if it had two circles and this was more parallel, it would be a cylinder. All right, and then our next example, example 3, we are going to describe cross sections. Okay, so a cross section is going to be what you get when you chop a shape with a piece of paper. Okay, so they're going to show you the shape in the cross section. This one is special. You can see that it intersects right here, and this is a cone. Now, because this is just one point, it's like it's sitting on top of the cone. So this one actually just intersects in a point. What if this cut further down? Do you guys know what the cross section would be? Yeah, good. Okay, if it cut further down, it would be a circle. It would match what the base is. Okay, which is going to be something that you're going to see a lot. So like for this one, the cross section, I'm just going to color in what the cross section is just to help you see it a little bit better. What kind of shape is that? It's a pentagon. Okay, does that match the shape of the base? Yes. Okay, so we'll just put a little note. Often, the cross section will be the same shape as the base. I'm going to say if it is parallel. So often the cross section will be the same shape as the base if the cross section is parallel to the base. Okay, so I don't want to say always because like we saw in this one, it could be just one point. Okay, if it was on top of a cone or a pyramid. Okay, but if these are parallel, they are going to be the same cross section. They're going to be the same shape as your base. Alright, and I'm going to give you your homework. I do not. 657. What is it? 567? 657. Okay, so I'm going to let you guys start on that.